Let's try an application that uses a change of base to reach an approximation. So the amount of light that reaches film is called the exposure value. So the exposure value of a photograph is modeled by this equation. F of t is log base 2 n squared divided by t. So we'd have a log function here. In this model, n is the f number, and that measures the aperture, the opening of the lens during the exposure, and t is the number of seconds of the exposure. So the exposure value for a photograph is depends on how open the lens is and how many seconds the exposure is. So let's say we want to find the exposure value for a given photograph. If the f number is 2.8 and our time of exposure is 0.25 seconds. So n is the f number, so this is going to be our n value, and t is the number of seconds of exposure. So right here we've got t, the number of seconds. So our exposure value for this problem is going to be f of 0.25 is going to be equal to log base 2 of that 2.8 squared divided by the 0.25. Now this quotient here is our entire argument of the log. So we're doing log base 2 of this value. Now my calculator won't evaluate log base 2. It will evaluate the common log base 10 or the natural log base e. So I'm going to use the change of base formula to get an approximation for this exposure value. So the change of base formula says I can change this to any base I like. So I'm going to change to base e for this example. So we're going to do natural log. And the argument in the numerator here is the entire argument here. So that's our 2.8 squared divided by 0.25. And the argument here is the original base. Then I'm going to grab my calculator and I'm going to evaluate this with our natural logs. So we're going to do natural log, and I'm going to enter this entire thing in the calculator. Let it keep that exact value. So 2.8 squared divided by 0.25, close off those parentheses, and divide by natural log of 2. And this gives me an exposure value, sorry, I got a tip here, exposure value of about 4.97. So there's an example of when we might need to use the change of base because we started with a base 2 here that my calculator was not able to evaluate directly.